Welcome again to the Windows Performance Deep Dive channel. In this video, we deep dive into exposing system activity during Windows startup. So we need to figure out why Windows is taking so long to restart and sign in. To do that, we need to capture an ETW trace from the moment Windows starts to initialize. We'll need to configure the Windows Autologger to capture the trace for us. Since this is a deep dive, we'll spend a minute exploring the Windows Autologger and how it works. The Windows Autologger runs early in the Windows startup sequence. It reads its tracing configuration keys from the system registry, and it starts the corresponding ETW tracing sessions. On some systems, there might be dozens of these Autologger traces pre-enabled. WPR, the Windows Performance Recorder, is able to add tracing configuration keys to the registry. But how do you tell it what ETW data providers to enable and what system resources to trace? The answer is that you specify one or more recording profiles. These are XML files in WPR profile format. So where do you find these recording profiles? There are some profiles built into WPR, but the MSO-Scripts script set provides its own set of carefully crafted recording profiles. And when you run a trace command with start and -boot, it instructs WPR to configure the system registry accordingly. At the next Windows restart, the Autologger launches the tracing sessions, including the ones for MSO-Scripts. Finally, when you run the trace command with stop and -boot, it stops the tracing session, it creates the event trace log ETL file, and it removes its configuration key from the Windows registry. We've already cloned or downloaded and unzipped the MSO-Scripts script set on GitHub. We'll need to run it in a Windows terminal or PowerShell or command window with administrator privileges. The key is to add the -boot switch to our trace commands. In this example, we'll use trace CPU. Optionally, adding -light here reduces tracing overhead by omitting thread weight and synchronization info. Doing start with -boot does not start tracing now, but it configures the Windows Autologger to trace during the next restart. So let's take a look at a few examples of what we can find. Here in the Windows Performance Analyzer, we have a CPU boot trace. It's the startup sequence of a previous version of Windows. Here we can see System and Windows Defender, and the Windows Explorer is launching here. That's the user interface. And the service host process is consuming one of the 4 logical CPUs from 37 seconds through the end of the trace. Expanding service host, we see that there are in fact various instances of the service host process running, and each of those processes hosts a variety of system services. To find out which services, we can enable the display name column. So that's the service display name. Turn that on. And here we see the names of the various system services being hosted by those service host processes. So we'll recolor them. This first one is going from 37 seconds through about 72 seconds. So we'll drill into that one to find out what it's doing. And here we see that it is trying to create a process, and that is getting intercepted by ci.dll doing validate image header, and ci.dll is wet. Switches over to the processes and modules, and we see that ci.dll is the code integrity module. So code integrity is going to validate the image headers of some module, and in order to do that, it first needs to load its catalog. And looking what it's doing there, it's parsing the catalog, and it's got a cryptographic signature. So the code integrity module is initializing its catalog, which is cryptographically signed, and the initialization consumes nearly 30 seconds. And later version of Windows optimized the way code integrity initializes. Now let's take a look at a similar trace from a Windows 11 device. Here we have a CPU boot trace of the Windows 11 startup sequence. As expected, we start off with system activity, and then there's service host with the system services, and there also. And then after about 3 minutes, I finally log in, and there's a variety of processes that are starting up. There's todo.exe, there's Pandora, and WhatsApp, and the Microsoft Office Hub. There is Defender. There is Search Host Cortana. I thought I turned that off. There's Defender. So what's happening there? Well, as soon as I log in, we see here in Settings under Apps and Startup, these apps are going to pre-launch in order to make it faster when you actually need to use them. But if you don't need them to pre-launch, then you can turn them off here in the system settings. Okay, let's take a look at what's going on with Service Host here. We know that Service Host hosts a variety of system services, variety of processes happening at the same time. We're going to find out which system services associated with those Service Host processes. We're going to enable the display name column, service display name, and there it is. So the first one is sysmain, and that formerly called the superfetch service, and that pages in data and modules from disk into unused memory called the standby list, and that is expected to speed up processes and operations when you launch them in the future. So let's look at what's happening there. I'm going to drill in, and we see that indeed sysmain is doing something about boot plan improve schedule, and we see that the thread priority there is level 6. Normal priority is level 8, so this would be below normal thread priority. So that would be operating in the background. When MSO-Scripts captures any Windows startup trace using the -boot switch, it also includes the data providers necessary to capture what's called a regions of interest chart for the Windows startup sequence. To see this, we go to Profiles, Apply, Browse Catalog, and we choose the fullboot.boot.wpa profile. Open. Now we select the Deep Analysis tab and maximize the top chart called Regions of Interest Full Boot. Here we see the various devices initializing and the various sign-in tasks executing. This display welcome screen is simply waiting for me to get around to logging in. Since we can trace almost anything, let's look at network activity during Windows startup. Here we do trace network with -boot. Whether or not we use the version in the beta folder makes no difference when collecting the trace, only when viewing it. Here we had captured a network trace of the Windows 11 startup sequence. You can see there's extensive activity from a variety of processes. I'll expand this column so you can see the different servers being contacted. Now, Service Host is several processes which host Windows system services, and they send and receive about 200 kilobytes in total. Of these, some service here uploads about 36 kilobytes to fe3cr.delivery.mp.microsoft.com. We'll expose some extra information. Alternate DNS name, status, and geolocation. So that server is also named something from trafficmanager.net, and it is in Amsterdam, North Holland. So this device is communicating with servers in a different country. Now we'll examine the stack block of code which initiated that network connection. I'm going to take full stacks, and that's the one I'll use this time. And let's see what we've got. So here we have the main thread, service starter WAUENG core, that is Windows Update service main. That thread launches another thread, which itself launches another thread, and that is the one which initiates the HTTP request. So there we have it. Quick and easy analysis of network activity during Windows 11 system startup. I hope you found this to be a useful introduction. You can find MSO-Scripts at github.com/Microsoft/MSO-Script. Do try it out, check out the extensive wiki, and let us know what you find.